let's start. First, instead of writing y equals 3x plus 2, right? This is the equation of the line. Instead of writing y, now we're going to write f of x, okay? This is a function notation. Remember, when we covered this, I said for each value of x, we do have a different value of y. So there is a relationship between x and y. Function is this relationship, okay? It's a relationship between values of x. Y depends on the value of x. So that's why we call it is a function, okay? So this is a simple function, a linear function. But let's start with the constant function. A lot of students ask me, I have problems graphing. You gotta do this, yourself. The standard way to graph any function is by making a little table of different value of x and f of x, right? Before we're writing y here, okay? So let's say I have 0. You enter any value of x. Remember, x is the independent variable, right? Is the variable that we can control. We can decide which value we want. Once we decide what value we want for x, y or function of x is defined, is determined, right? For instance, if x is 0 on a function, there is a constant function. The constant function, an example would be f of x equals to k. K is any number, right? For instance, it could be f of x is 3. So what's going to happen? Is there any variable on this side? No, right? There is no variable here. So when x is 0, it's not going to change 3, right? It's not going to change the value of function, so it's going to be 3. When it's 1, it's 3, 3, 3. So it's always 3. So what does that mean? What is this line going to look like? Yes, can say it? Horizontal. It's going to be a horizontal line, right? So if we graph that, it's going to look like this. Where is f of x is here, and x is here. So 1, 2, 3. 3 is right here. So when x is 0, 3. When x is 1, 3. 2, 3. So it's going to be flat line. It's horizontal. And what is the slope here? The slope here is, what is the slope? Anybody going to say anything? 0, right? 0. Okay. The slope here is 0. Good. So let me erase this. So let's make a little draw here so you remember this. So I like you guys to have this table so you can visualize, how the functions look like. This is very important, So there you go. So that's the first graph. That's a simple graph, easy, right? Easy to make. And so let's go to the next one. The next one is linear function. So this is the simplest example of a linear function. F of x equals to x, okay? F of x equals to x. So let's do again the table, right? So x and then f of x and then 0, 1, 2, and 3. And let's see what happens. So when x is 0, right? F of x is 0. When x is 1, f of x is 1, and 2, and 3. There you go. So then we graph again this, and 1, 2, 3, 1, 2, 3. So when x is 0, f of x is 0, first point. When x is 1, f of x is 1, second point, and third, and fourth. And we see that this is going to be a straight line with the 45 degrees, right? Is the the relationship here is the identity, is exactly the value of x is the value of the function, okay? Now, let's do some, what I like to say, the massage here. Let's do some massage here, right? If I want to add a number, if I want to do f of x equals to x plus 2, what do you think is going to happen? Mia, what do you think is going to happen if I, to the graph?
Oh, the y-intercept would be 2.
Yes, that's correct. So let's do that. So if you want, I can do the table here again, right? And see what happens, right? So 0, 1, 2, and 3. So when x is 0, now I'm going to have here 2, and then 3, and then 4, and then 5, and then 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. When it's 0, it's 2, that's correct. And then 1 is 3, is here. Then 2 is going to be 4. So, and then I can graph that here. So what happened when I add 2? What happened to this line? Moved up, right? By adding 2, the line just moved up. Okay. That's important to know. What if I had now f of x equals 2x? What's going to happen now? What is this 2 is going to do to the line? What is the 2 going to do to the line, to this line?
Increases slope.
Increases the slope, so that means the line is going to shift up, right? Higher, okay? All right, so is this okay with the linear equations, right? Now, if the line is going to shift higher, it's going to look like this, because now when x is 1, f of x is 2, so the point is here. It's moved from here to here, okay? So the line has gone steeper. And if I add 2 again here, if I make f of x equals 2x plus 2, what's going to happen is now this whole line is going to move up by 2. And it's going to be a parallel line. It's going to be a parallel line, okay? It's going to be a parallel line. Very good. All right, so let's move on now to the next. And then let me do a little draw here so you guys remember this is, how the line is going to look like, okay? So the general form of this linear function, we can say that the general form of the linear function is going to look like this: mx plus b, where m is the slope and b is the y-intercept. Now let's focus on the quadratic function, okay? Quadratic function, the x squared. So again, f of x is x squared, and again, let's do the table, f of x, and then 0, 1, 2, and 3. So when x is 0, x squared is going to be 0. When it's 1, it's going to be 1. When it's 2, it's going to be 4. When it's 3, it's going to be 9. Okay? So let's do the graphing here and see how this is going to look like. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So x0, f of x is 0, 1. When it's 1 is 1. When it's 2 is 4. When it's 3 is 9. Okay? So we see that the line is increasing faster, right? It's increasing faster than the linear equation, and it has this shape here. Now, let's look to the negative side. Let's look to the negative side, what's going to happen. When I have negative numbers here, because this is the square, this is not going to change. It's going to be the same. So that means when I have here -1, -2, -3, the line is going to just be symmetrical to this one, to the other side, okay? It's going to just flow the same way as the other one, okay? So this is what we call the parabola, right? Parabola. Is that okay? Now, let's think about if I had f of x plus 2. If I add 2 now, what's going to happen? What's going to happen to the function, to this function, if I add 2 to it?
Shift upward.
Shift upward, right? Very good. So instead of starting the minimum being here on 0, the minimum now is going to be here at 2, okay? And it's just going to move the same way like this, all right? We're going to move that way. What happens if I now, instead of adding 2 to the x squared, I add 2 to x. Let's say if I add 2 to x here, right? 2x squared. What do you think is going to happen to this curve? Where is the minimum going to now? Anybody? It's going to shift to the left, right? It's going to shift to the left. So what's going to happen? The minimum now, right? This is going to be 0 when x is -2, okay? When x is -2, it's going to shift here, right? So let's do this graph here. Just, you know, if you don't believe me, let's just do the, you know, the table again. That's what I want you guys to do at home, you know. Each one of these examples, you know, write the table and actually, you know, collect the data and do the graphing. That's going to build up, you know, self-confidence for you to handle graphs, and also it is possible for you to from the graph to write the equation, right? We want you to be able to graph what given a function, and also given the graph, you know, be able to write, you know, the functions for itself, the equation. So let's do here some -2, -1, 0, 1, and 2, and see what happens when this is -2. When this is -2, -2 and +2 is going to be 0. So 0 squared is 0. There you go. When this is -1, -1 and 2 is going to be +1, and it's going to be 1. When this is 0, when x is 0, this is going to be 2 squared, so it's going to be 4. When x is 1, there's going to be 3. 3 squared is 9. And when it's 2 plus 2 is 4, squared is 16. So, so here you go, -1, -2, 1, 2, 0, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So here you go, 0, first point, right? -2, 0. -1, 1. 0, 4. 1, 9. You see now that it has moved. In fact, this has moved to this side. And if I do -3, let's do -3 to see what's going to happen. If I have here -3, -3 plus 2 is -1 squared is going to be 1. So it's going to be here. If I make it -4, negative 4 and 2 is going to be negative 2, and it's going to be 4 here. So you see that, you know, the shape of the parabola is going up here and has shifted from 0 to negative 2. So the minimum now is in negative 2. Okay? So, let's do the multiplication here and see how this is going to look like. If I multiply, right, this is a square of a binomial, the square of a binomial. If I have x plus 2 square, what's going to be? It's going to be x plus 2, x plus 2, and if I multiply x times x, it's going to be x squared, x times 2, 2x, 2x, and then 4. So I have x squared plus 4x plus 4. This is actually equal to x squared plus 4x plus 4, right? So this function is the same as writing x squared plus 4x plus 4. Now notice that this here is the square, x times x is x squared, and 4 is 4, 2 times 2 is 4. It's the product of the first numbers on the binomial, and this is the product of the last two numbers on the binomial. Now, when you set x equal to 0 here, right? When we set x equal to 0, what is that we finding? We finding the y-intercept, right? When you set x equal to 0, look, this is going to be 0, this term is going to be 0, this term is going to be 0, so f of 0 is going to be 4, and it is exactly here, that's the y-intercept, you see? So that's how a quadratic function looks like, right? It's going to be a parabola. Now, if I had here, if I now increase f of x, let's say I put a constant in front of it, what do you think is going to happen? If I multiply by a constant, what's going to happen to this original x squared? What's going to happen? If I now, instead of f of x, I have 2x squared. It's going to shrink, right? It's going to shrink this way, right? It's going up faster, right? It's going up faster. Okay, what else we can talk about here? Also, if I had another function now, I'm going to write here on this side, if I have f of x equals x plus 2 squared, we know when we do this, we have shifted this to the left. Now, if I add, let's say 4, what's going to happen now to this one? It has shifted to the left, but if I add 4, what's going to do? Yes? What's going to do it? I have shifted, when I add 2 to the x, I shift to the left. But when I add 4, what's going to happen to this whole graph? It's going up, right? It's going up. So please, at home, make sure you, make the table for this one so you confirm that, okay? So you are comfortable. You're only going to be comfortable doing these graphs, by doing yourself, to actually building this table, all right? Okay, so now let's make my little draw here, so it's a reminder, so you know this is a parabola, okay? And actually the general form for the quadratic equation is going to look like ax squared plus bx plus c. So let me erase all this now. So what are we doing? We are covering a function. We also trying to understand how the function behaves and how we can move functions, transition function from to the right or to the left or up or down. Now the other function is the square root function, okay? The square root function is basically, you know, the inverse of the square root, right? Of the square. Square root is the inverse of the square, right? So again, f of x equals square root of x. Let's do the little table here, x, and then f of x. And when x is 0, x0 is going to be 0. Let's put 4, x4, because square root of 4 is 2, makes it easy. And then the next x is going to be 9, and then 3, okay? So now let's graph and see how that function is going to look like. So I have here x1, 2, 3, 4, 5, 6, 7, 8, 9. And then here 1, 2, 3. Okay, so when it's 0 is here. When it's 4 is 2. And we can put even when x is 1, this is 1, so 1 is here. And then 9 is going to be 3. So the function is going to look like this. It's like a parabola, but now instead of being like this, it's like that, okay? So that is how the square root of, how the function of the square root is going to look like, something like that, okay? All right? Let's move on to the next one, the cube function. So f of x cube. Again, best way to graph is by doing the table. And I can start with negative, let's say -2, -1, 0, 1, and 2. So now here, when this is negative, because the exponent is an odd number, it's going to keep the negative sign. It's different from the quadratic function, right? The square, the negative would cancel. Will always be positive. But in this case here, -2 times -2 is going to be +4, times -2 is going to be -8. And then -1 is going to be -1, 0, and then 1 and 8. So here again, let's see, 1, 2, +1, +2 here, and here -1, -2, and then 1, 2, 3, 4, 5, 6, 7, 8, 1. So when it's 0 is 0, when it's 1, it's going to be 1, and when it's 2, it's going to be 8. Right here, it's going up very fast, but here on the negative side, it's going to be just the opposite. When is -1 is going to be -1, and then 2 is going to be -8, somewhere here. So the function is going to look like this, okay? It's like if I had here the parabola somewhere here, you know, this has just flat back to the bottom. So now here this is going to look something like this, okay? All right? And those things, again, if I were to do f of x -2 cube and then +4, you know, would move to the right and then move up the same way with the square. So please, at home, try to do this one, you know, on the table, and you're going to see that this thing is going to move to the right and then would move up 4 units. Okay? what happens is students, they need to do it, okay? You guys need to do it yourself, so you feel confident in how these things work. Now, another important function we're going to review now is called the reciprocal function. The reciprocal function looks like this, 1 over x, and again, table x, f of x. So let's start with maybe -2, -1, 0, 1, and then 2, and see what's going to happen, okay? Well, when, let's see, there we go, 1, when x is -2, it's going to be what? -1 over 2. When x is -1, it's going to be -1. When 0, what's happened with 0? Wow. Well, that's undefined, right? Okay, let's put here undefined, okay? When it's 1, it's going to be 1. When it's 2, it's going to be 1/2. And let's continue. When it's 4, it's going to be 1/4. And when it's 10, it's going to be 1/10. So we can see that as x is increasing, this number here is actually decreasing, right? It's becoming smaller and smaller. So let's see. 0, so is undefined. We don't know where it's going to. And then 1, when it's 2 is half. When it's 4 is 1/4. And when it's 10. So the line looks like this. And we can see we'll never go to 0, right? We never reach 0, but it's going asymptotically to the x-axis. And what's happening here is basically the same, but on the negative side. So 1, and then half, and then like this. So it's going to happen like this. Now let's analyze this area here between -1 and 1. What do you think is going to happen? Well, let's think about half, when it's half. If x is half, what's going to happen? When x is half, 1 over 2. When x is 1 over 2, what is the value of the function? 1 divided by 1 over 2 is 2. When it's 1/4, 1 divided by 1 over 4 is 4. So we see that this here now is actually increasing at a very fast rate, and will go up very quick, but we'll also, again, we'll never intercept the x-axis. So there is no y-intercept here. When x is 0, there is no y-intercept. So that's how the reciprocal function looks like. I'm going to do that here, so you guys have a little table. Please make sure you save this table, and so you'll be able to review it, okay? And visualize how the functions look like. So if you see a function like this on a test, and they ask you to write the equation, so you know where to start from, okay? The next function is the exponential function. Well, we call exponential function because the variable is actually an exponent. An example of an exponential function would be 2, constant, any constant, could be 3, and then to x. So let's see how this is going to work. Again, let's make a little table. Let's say x, and then f of x. -3, -2, -1, 0, 1, 2, and 3. So if it's -3, so 2 to -3 is going to be like 1 over 2 to 3, right? So it's like 1/8. 1/8. 2 is going to be 1/4. 1 is going to be 1/2. 0 is going to be what? What's going to be, if I have an exponent 0 here, it's going to be what?
1.
1. Thank you. 1. And if it's 1, it's going to be 2. And if it's 2, it's going to be 4. And if it's 3, it's going to be 8. Okay? So this one, we actually have a y-intercept, right? The f of x. What is the intercept here? The intercept is at 1, right here, 1, okay? When x is 0, the function, the value of the function is 1. When it's 1, it's going to be 2. When it's 3, it's going to be 8. Somewhere here, okay? So we know from the positive side, it goes up, and it goes up very fast, okay? Now, to the negative side, when it's 1, it's going to be half. When it's 2, it's going to be a quarter. When it's 3, it's going to be 1/8. So we know this is going to be like this. But again, this number can go very far here on the negative side, but will never intercept the x-axis, okay? So the exponential function is going to look something like this, okay? So that is the exponential function. All right? Okay. All right, so let's erase this. Now let's talk about our next function is called the absolute value function. Absolute value. Well, special about absolute value function is because it is actually a measurement, right? It is the distance of any point to 0. So to graph that, we would again have to do this table and -2, -1, 0, 1, and 2. And all is going to be positive. So it's going to be 2, 1, 0, 1, 2. So when we graph that, we are amazed to find that this function is actually a straight line on this side, but on the other side, it's going to be also another line. So it's a V of victory, okay? So now let's think about what happens if I add 2 inside the bars of the absolute value. What happens to this V if I add a 2 there? Where is this V going to move to? Yes? Where is it going to move to? Anybody? It's going to move up? If I add here, x, it's going to move up. It's going to, this one, when x is 0, I have this 0 here, right? But what is the 0 now here? Where's the 0 now here? So let's do the graph, okay? If we don't know, the best way is actually to do the graph. So let's see, -2, -1, 0, 1, and 2. So when x is -2, -2 with +2 is 0, okay? When it's -1, it's going to be 1, it's going to be 1. When it's 0, it's going to be 2. When it's 3, 1 is going to be 3. When it's going to be 4. So actually, what happened, let's try -3 here. -3, see what happened. -3 with +2 is -1, it's going to be +1. So we see what happened is this point here has moved to the -2. You see that? You see that now? So when you don't know, what are you going to do? If you on a quiz, right? And I say, you know, graph this, you're actually going to do this table, right? Don't just, if you're not sure, or, you know, if you've done this a lot of times, and I hope you do at home, then you'll be able to figure out right away, well, if I add 2 here, what's it going to do? It's going to shift to the left. If I subtract by 2, it's going to shift to where? Where's it going to shift? If I subtract by 2. If I write this function, x minus 2, and then the bar, what's going to happen to this one? It's going to shift where? If I add, shift to the left. If I subtract,
Right.
shift to the right, okay? Now, if I add 4 outside the absolute, then it moves up 4 units, okay? So, so the best way is I would suggest that you do this graph at home, then you do this one, then you do the -2, then you do one with +4. If you do all this in a 15 minutes time frame, I guarantee you get, you know, understanding about how the function moves and how this function works, okay? That's the only way. We covered this before, but I'm doing this as a review again. And, if you still don't try yourself at home and rely only on listen to what I'm covering here, it's not gonna work, okay? It's not gonna work. So please make sure you do all those things yourself. I'm making here this table, and I hope you you copy that and make a little table for yourself, and so you kind of become familiar with them, and don't be so scared, you know, when you see, you know, a function. Say, oh my God, a function, what am I going to do, you know? Graphing is easy, right? If you follow, you know, steps, you know, what you need to graph, you just need to make a table. That's simple, you know. If you recognize the equation, if you've done that over and over many times, like we have done with, you know, the linear equation, then you can, you know, pretty much draw the function without making big tables. So let's now look at our last function, the step function. So the name of the function is already giving you an idea how the function is going to behave, right? And here I'm giving an example. So this function is going to behave f of x equals to x if, for instance, if x is greater than 2, you know, could be any number, right? So if it's greater than 2, the function is going to behave like f equal to x. Now, if x is less or equal than 2, then it's going to work like a square, a quadratic function. So again, we can make a table. We can make a table here for this, okay? And we have to remember that there is a transition here right at 2. So I can make here -2, -1, 0, 1, 2, 3, 4, 5, and see how this is going to behave, okay? So when x is -2, -2 is going to work like this one, right? It's going to be the square. So -2 here is going to be a 4, right? When it's -1, -1 plug in here is going to be 1. When it's 0, it's going to be 0. When it's 1, it's going to be 1 again. But when it's going to be 2, it's going to be 4 again, okay? Because that includes the number 2. Now, 3 is different, right? 3 is different. 3 is greater than 2. So now the function is going to behave like a linear function, so it's going to be 3. Okay, so let's make a line here just so we know there is a step here, right? There is a transition. In this range, behaves like quadratic, and in this range, it's going to behave like a linear. So when x is 4, it's going to be 4, and then 5, and so on. Okay? So this is the step. This is the transition. So let's graph this now and see how this is going to look like. Okay? So -1, -2, 1, 2, 3, 4, 5. Okay? Now, what is the transition period? The transition is right here at 2, right? So let's put a dotted line to remind us that, behavior is going to change. So negative 2 is going to be 4. 1, 2, 3, 4. So I have a point here. Negative 1 is going to be 1. That's a point here. 0 is here. 1 is here. And then 2 is here. And it's solid. And I can draw my line right here, like this. Okay? So the function behaves like this, and here continues, right? Continues. So this range here, for x equal 2 or less, it behaves as a quadratic equation. Now for above that, 3 and 4, let's see what's happening. When x is 2, here it's going to be 2, right? Right here, 2, 2. So, but it's going to be an open circle here, okay? Open circle, because it's just saying is x greater than 2. When it's 3, it's going to be 3. When it's 4, it's going to be 4. When it's 5, it's going to be 5. So again, it's going to be a straight line. So that is the step function line, okay? So it behaves as a quadratic up to 2, and then from 2 up. Different ranges, okay, different intervals, okay. The domain here, this domain from less infinity to positive 2 is a quadratic range, right? It works as it functions like a quadratic, and then from 2 and above is going to be a linear equation. All right? Okay. Thank you. Make sure you copy this table, okay, and look at it every day, right? Make sure you look at this table every day, right? And all this, how they look like, and so this way you will remember. Okay? So we have videotaped this class.